going to discuss the concept of a corner point in this section. A corner point of a solution region is a point in the solution region that is the intersection of two boundary lines. Okay, so take a look at this region here. I actually highlighted the boundaries for you. So notice this boundary region right here, and see it's shaded inside here. Okay, now if you'll notice here, there are actually five corner points here. So notice that the corner point 0, 0 is a corner point. So let me make sure I highlight all of them. 0, 0 is a corner point here, because 0, 0 is the intersection of the y-axis and the x-axis. Now this point is the point 0, 10. 0, 10 is a corner point because it is the intersection of this line with the y-axis. And then this point here is the point 11, 0, and 11, 0 is the intersection of this line here and the x-axis. And then this point 9, 4 is actually the intersection of this line and this line. And then this point here, this point 5, 8, is the intersection of this line here and then this line here. Okay, so those 5 points are corners that fall within the region. Now there are several points that are not corner points that are also the intersection lines, but since they're not in the region, they're not corner points. Like right here is where that line intersects the y-axis, but that's not a corner point because it's not in the region. Here's another one here. That's not a corner point because it's not in the region. And here's one right here. This point right here is not a corner point because it's not in the region. Okay, or on the, when I say in the region, I also include on the boundary. So the 5 corner points are just those 5 corner points that I circled for you there. All right, now let's talk about a more complicated system. Now I'm going to start using x1 and x2 for my variables here instead of x and y, and you'll start seeing this more and more. Okay, so now I have 3 inequalities here. So let's look at the first one. The first one is 2x1 plus 4x2 is less than or equal to 24. So the boundary is 2x1 plus 4x2 equals 24. And so x1, if x1 is 0, then x2 would be 6. So that would give us this point here. Okay, since I've got it highlighted, I won't try to draw it. But there's the point 0, 6. And then if x2 is 0, you can solve for x1 and get the point 12, 0, which would be this point. And then you would draw the line through them. It would be a solid line. And then you could test the origin here, 0, 0. And you can see if I plug 0, 0 in, I actually get a true statement. So I shade everything on the 0, 0 side of that line. So that would be that region. Now let's bring in the second inequality and see what we get from that. So I have 3x1 plus 3x2 is less than or equal to 21. So its boundary would be 3x1 plus 3x2 equals 21. Now if you let x1 be 0 and solve for x2, you get 0, 7. And also if you let x2 be 0 and solve for x1, you get 7, 0. So this line goes through 0, 7, and it goes through 7, 0. And then if I draw the boundary through that line, I would draw this line. And now notice what I did here. I took this region, this shaded region, and I brought it over here. And then I drew this line on top of it. And then I've got to determine which side of this line to shade. So if I'm going to test the origin here again, right here. So if I test this origin 0, 0, notice I get a true statement again. So I got to shade everything on this side of that line. Now if you look at the overlap, if you shade everything below this line and then you shade everything below this line, then you're going to get this dark green region that you see. it's bounded here by the red line, and it's bounded here by the green line. So it actually, you know, comes down here and changes boundary right here to this one, and then it's, you know, all the region that goes on, and it goes on forever and ever and ever in the, you know, in this direction. Okay, and then finally what I'm going to do, I have a third one here that I'm going to bring in, and let me go ahead and show you the third one without putting it in. So here's the third one. So if you look at this third one, the boundary would be 4x plus 2y, or just 4x1 plus 2x2 equals 20. That would be the boundary. So if you let x1 be 0 and solve for x2, you get 10. If you let x2 be 0 and solve for x1, you get 5. So this one goes through the points 0, 10, which is right here, and 5, 0, which is right here. But on this one, notice the inequality is actually greater than or equal to, and so if I test the origin here, I get a false statement. So if I test the origin here, I get a false statement. So that means I got to shade that line. So now if I take this shaded region and move it on top of this region that I had over here, if I put it on top of it, then what I'm going to have is it's going to come in through here like this. And remember that big green region I had up there above? Well, now it's actually going to cut into that, because it's going to cut into that, and I'll just try to show you here. It's going to kind of cut into that like that, and then I'm going to shade everything to the right of this, or really it's above it, but it looks like it's to the right of that. And then it's just going to give me this sliver right here. So the overlap of all three is just going to be this triangular looking sliver right here that's coming out. And so it's right here. So let me see if I can kind of show you here. Let's see if I can find my, there we go. Let's go up there like that. Whoops. Give me a second. I'll get it right in a minute. So go up there, and then out here like this. Okay, so all right, hopefully you can tell now that these red lines here kind of show you the region. So it's everything in here, and again it's an unbounded region because it still goes down forever and ever and ever in this direction. Okay, so that's your region. Now this region, if you actually found the intersection of the two lines right here, you would actually find that that's the only corner point. Ignore the 5, 0 and the 7, 0. Those aren't corner points. But right here is the only corner point for that unbounded region. Okay? And to get that corner point, you have to know the two lines that make it up. And it's these two lines here. Actually, I wrote the inequalities, but it's the lines 3x1 plus 3x2 equals 21 and 4x1 plus 2x2 equals 20. And if you solve that system of equations, then it'll give you the solution right here, the 0.34. Now, I'm going to kind of go out of order here, but I want to look at this practice problem. If you'll notice, these were the three inequalities that I just drew. And then I want to throw on that x and y are also greater than or equal to 0. I really should have said x1 and x2. But x and y, hopefully you know what I mean. But anyway, x1 and x2 are greater than or equal to 0. If I do that, if I tell you that, then that means that I only include the portion that's in the first quadrant. So if you go back and look at what I had graphed earlier, remember I had this triangular looking shape that went on forever and ever, but if I'm restricted to the first quadrant, then it's going to be bounded right here by this little piece of segment here, and those 2 points are actually the 0.50 and the 0.70. So by just throwing in those, the x1 and x2 being greater than or equal to 0, it actually makes this be a bounded region. And so if you take a look here, you can see the it goes here, and then up here, and then it comes back down here. So that's your region, and that's a bounded region, and it has 3 corner points: 3, 4, 5, 0, and 7, 0. And we knew these two. We saw those if we identified those when we were graphing the lines. So we knew this was 5, 0 and this was 7, 0 from our earlier graph. And then of course I already told you where you got this point. This point is just from the intersection of 2 of your lines. So you just solved a system of equations to get that point. And so that would be a bounded region. Okay, let's do one more on this video. Let's say I have 2x plus y is less than or equal to 22, x plus y is less than or equal to 13, 2x plus 5y is less than or equal to 50, and x and y is greater than or equal to 0. So the boundary 2x plus y equals 22. I think you know how to get the intercepts. If x is 0, y is 22. If y is 0, x is 11. So what you would do is you would draw the line that goes through 0, 22, and 11, 0, and then you would test the origin here. And so if you test the origin, this point here, then you actually get a statement that's a true statement. And so you would shade everything on the same side as the origin. And then the other one goes through 0, 13, and 13, 0. So if we lay that on top of that graph, 0, 13, and 13, 0, and then we test the origin there, plug 0, 0 in for that line, what's going to happen, we're going to get another true statement. So we're going to shade everything below this line as well. And now I've got this dark green region. Okay, so that gives me that dark green region that you see. That's the overlap. And then finally I've got a third one, 2x plus 5y is less than or equal to 50. So the boundary there would go through, the intercepts would be 0, 10, and 25, 0 for that one. And so that would, so then if I go through here, 0, 10, and 25, 0 is right here. So if I draw that line through there, and then if I test the origin 0, 0, I get a true statement for that one as well. So I shade everything below that line. And now if you shade everything below this line and everything below this line and everything below this line, then where you're going to be bounded, your boundary region is going to look like this. So you're going to be bounded here by that line, and then it's going to change boundary to this line here from here to here, and then it's going to change boundaries to this line right here at this point. And actually you can see that we shade everything below that, so that dark purple region that's shaded below that would be the region. But we're still not done. That's only the region if we did not have these guys, the x and y is greater than or equal to 0. But since we know we have these guys, the x and y is greater than or equal to 0, then now I have to restrict it to only the first quadrant. So that means I would be cut off here by the y-axis, and I'd be cut off here by the x-axis, and then that would give me this region here. So now you can see that the region would be this, looks like a 5-sided figure here in the first quadrant. And the corner points, this was 0, 10, 0, 0. This point is 11, 0. And then if you solve the appropriate pair of lines to find this point, you'll get that this point is at 9, 4. And then also to solve the appropriate pair of lines to get this point, you'll see that this point is at the point 5, 8. So these are your 5 corner points for that region, and that region is actually a bounded region because you can enclose it. You can draw a circle around it, so therefore that's actually a bounded region. Okay, in the next video I'm going to go ahead and wrap up this section, and at the same time I'm going to introduce you to the concept of linear programming.